This meeting is being recorded.
Welcome. Today is Wednesday, the 15th of May, 2024, and this is the Cluster API Karpenter Feature Group meeting. We follow the Kubernetes SIGs, guidelines and whatnot. So, let's do that. Anyways, just two of us here today, and I only had one topic on the agenda, which is basically, we're preparing for this. We're going to have a deep dive meeting tomorrow with Fabrizio to talk about a bunch of the topics, that we've been going through. And I was going to say, I could open it up quickly, just to kind of go through some of the issues that I've been trying to deal with here. And these are the topics that I'd like to discuss tomorrow with Fabrizio. So one of the things, as we're switching, Fabrizio wants to see us switch from kind of the orphan machine approach we had taken before to something that uses machine deployments on the back end. And I think he makes a good argument for it, which is, cluster API users put a lot of they put a lot of knowledge into the machine deployment, and the machine deployment contains things like, replacement options and how things should grow and shrink. And so we should leverage that knowledge so the user doesn't have to repeat it in a Karpenter way or something like that. And I think it makes good sense to leverage that, but it makes things different. So in the previous way I was doing things, if Karpenter asked to create a machine, we could just create the machine directly. And so we'd know what its provider ID was and everything. But if we switched to using machine deployments, the expectation is that I'll increase the replica count and something else will make a machine. And then I'll need to figure out what that machine was to get its provider ID to give back to Karpenter. So that's kind of one of the issues I think is a big one, although there's probably ways to solve it. Another issue, although I think we have a solution for this as well, is deleting a specific machine. So cluster autoscaler normally just wants to increase and decrease replicas. Rarely it will ask to delete specific machines. And when, them with and then we also increase the replica count. So I'm guessing Karpenter is going to have to do some knowledge of node groups, all individual instances. So it's going to be delete this, delete that machine, and we're going to have to figure out a way this happen in a way that's not.
Your audio is breaking up a lot.
Oh, really?
Yeah.
I wonder if this is another review web client. I think I'm going to increase my mic volume a little. Maybe it's cutting out because it's not picking up my voice or something. Or does it sound like bandwidth? Is it just terrible to can you hear me at all?
It was just dropping out. So this is actually a bit better.
Okay, cool. Maybe it was just a little bit low. Okay. So another issue is the resource capacity information, right? Right now we've defined the scale from zero annotations, and I'm going to leverage this heavily in terms of being able to look at a machine deployment and then know what size the machine is and everything. So in at least the proof of concept, I'll make heavy use of these annotations and maybe others to do things like putting pricing information on a machine set or, whatever. But this is a big problem that Cluster API has to solve because right now we have, as part of the scale from zero effort, we're able to place capacity information on the infrastructure templates. But that's the only place we have it kind of expressed aside from the annotations. So we need to kind of figure out in the Cluster API land, what's going to be appropriate for this. Are more providers going to participate in this style, or is it all going to be left up to the user to add these annotations? We'll probably have to do some work to understand what's the best way to expose those things. And then there's a bunch of general questions, even beyond using machine deployments, how do we know what a node zone label is going to be? How do we know what the labels on the node will look like? Just from the machine set, how do we know that? Same thing, instance type naming. How do we want to name instances that we provide to Karpenter? And this is Karpenter wants to have kind of classifications for different names. And I don't know that it uses them that way internally, but we probably have to have like unique names. And, this might be like we just have to use the machine deployment names or some transformation or something. I don't know yet. Offerings is another huge one. And I think users are going to be really interested in this, which is, what inventory is available, how much does it cost, those kind of information. And, the Azure and AWS versions of Karpenter, they plumb directly into the back end for Azure and AWS. So they are providing this in like real time whenever Karpenter makes a query. We've never gone this direction in Cluster API, and I brought the topic up a few weeks ago at one of our meetings. But this is like a big question we have to solve. Is there an API that we can develop in Cluster API where, like capacity information and whatnot, we could see price information coming through CAPI objects? And I think if we can solve that, it'll make a big deal for like people writing kind of day two tooling and everything.
For us, I'm sorry, just
no, please, please.
For us, the pricing information is a little bit of a problem because while Karpenter interfaces directly with AWS to get its pricing information, that pricing information is not necessarily Adobe's AWS pricing information, right? It's just the regular like market pricing. And so provided that Adobe's unit cost and the unit cost for the general marketplace are in the same relative position in that list, it still works the same. But if we have a cheaper unit cost on some instance type, we're going to need to be able to somehow get that custom pricing and have it, make sense to really get the, benefit out of that kind of selection. And that also doesn't get into like, Karpenter right now isn't ODCR aware. And so when we have our own special categories, we need to be able to accommodate those as well.
Yeah, I mean that's a great point, and it's something that I know has come up before. Where if you've negotiated special rates and special like SKUs and whatnot, how do we express those in a way where they get utilized? Because otherwise, what would be the point of doing all this, right?
Yep.
Yeah. So great point, and I made a note there because I don't want to lose track of that one because I think that's even tough to handle like today with Cluster API, right? And then the last thing on the list right now is taints, and we don't have a good way aside from, and I didn't list it here, but there are Cluster API annotations that we can use on the machine deployment to tell what taints will be there. But aside from that, we have no way to know like what taints are going to be on the node, and so it makes it very tough to schedule these things from a predictive standpoint. And I think a lot of this comes down to we need a way in Cluster API to say, given this machine deployment, like what does the node look like that I make out of this? What's the capacity? What are the labels that are on it? What are the taints that are on it? And if we could figure that out, that would be great. I don't know if we will be able to figure it out or not, but I guess that's why they pay us the big bucks, right?
And there's the question there of, you could always take what you have defined in machine pools, put them through some kind of transformation, and then create those node pool objects. But is that really the best option to handle that? Because then you can end up with drift between the two of them, and obviously that's not desirable either.
Right. And ideally, there's going to be some way for us to express the drift in a way that Karpenter will be able to pick it up and then like fix it for us, right? Like that would be the ultimate expression of this. I think that we're a long way from that, but I'm very curious to see how it goes. So these are the topics we're going to get into tomorrow. And I think, I've been just pushing ahead, trying to just get as much work as I can done on the POC. And, we're still probably several weeks away from the point where I could really start collaborating heavily with others, but, we're making progress. So hopefully we'll get it working soon.
Cool.
Were there any topics or things you wanted to bring up?
Not specifically. I'm just trying to pay attention so I know what's coming up, because we are going to migrate to Cluster API eventually. We're doing the Karpenter migrations right now, rolling over onto Karpenter on a lot of our clusters. And so when we do go to cluster API and we have Karpenter already deployed, that in theory simplifies our migration a bit because we don't have to rebuild all of our old infrastructure in cluster API. But we need to understand that path forward. And with everything moving so fast in this space, I'm worried that, I miss a week and it's like suddenly we went in a direction that's, created 10 times the work for us.
Yeah, those are good concerns to raise. I keep trying to go back to the notion of one of the things we need to stay true to in this feature group is providing the best cluster API experience we can, right? So like someone who's in your position, if you're making this migration to cluster API and you want to keep using Karpenter, it's not like some new knowledge you have to learn, right? Like you can just keep using cluster API the way you expect to be using it, and then you can add Karpenter in, and it kind of makes sense to you that it's like, okay, I defined my node pool, and I can see that it's coming from the machine deployments on the other side. And then it becomes very easy to reconcile with the notion of, okay, machine deployments define the inventory and node pool defines the mapping to get to that inventory. So like I'm hoping that we can, not degrade that experience for people, but it's going to take a lot of work to get there, I think.
Yeah, one concern that I do have is what adding another abstraction layer over the top of Karpenter is I think we also need to be aware of that and try to avoid making things more slow. I've seen some Karpenter scaling times where nodes are coming up in 30 seconds. And that's fantastic compared to our cluster autoscaler times of 3 to 7 minutes. Some of that is that we're using flatcar and ignition, and that causes some slowness there. But Karpenter going directly against the APIs is does seem to be a lot faster with less overhead than ASGs and node templates and whatever else is in there. So
Yeah.
just avoid slowness, because this scaling speed really plays into optimizing cluster space, because if we can get nodes out there reasonably fast, we can get rid of over provisioners. We don't have to have as much capacity just sitting around for workloads that really need to move incredibly fast.
I mean, that it makes a lot of sense to me. And you're not the only person I've heard talking about kind of like how quickly do nodes come up and whatnot. And I think this is where it's going to get really difficult, because in in situations where you have like more managed Kubernetes type inventories of machines that are coming up, like the scaler can keep them hot for you, right? And if like if I'm running Mike's managed Kubernetes service and I know I'm handing out Kubernetes on certain versions and whatnot, I can like prime a node at a certain kube version and just keep it waiting, but not attach it to anything. And then when you request it, I can be like, all right, I can attach it real quickly, right? And so I can make a better experience on my managed platform because I can really scale things like unbelievably quick because I'm keeping them kind of hot on the back end. And I think that might be one of those things where it's an interesting pattern to talk about from the cluster API perspective. Like, how would you do this, or how would you interface with this? And how would you do it in a way that wouldn't mean that I would have to take all the cost? Like, is there some way that we can, that I can use hot machines that are ready? So yeah, I think what you're talking about, the time to make a node is definitely, I see a lot of people talking about it, or maybe not a lot, but some people.
Yeah, the concept of hot nodes and empty slack space like that is it's simple, but it can get kind of complicated when you're us, right? Because we are running clusters in Azure and AWS for Adobe engineering teams, and so we need to keep space available for them, but that means that everyone's paying for it. If we, if AWS is able to keep those nodes warm for us, like, okay, so what's the pricing there? But they don't offer that as a service
Right,
at the
right.
moment. And how does that play into the way that we build our clusters and manage our clusters? And would something like that even be compatible?
Right, right. And you're kind of exactly spot on there. Like, you don't want to be the one kind of holding the bag as it is. You don't want to be like, you don't want to be keeping the spare instances in Adobe's infrastructure, because then you're just paying for instances, right? So I totally get you. And it's just, I think it's an interesting problem, and something we probably need to bring up in the cluster API kind of general community too.
Yeah,
But
I mean, it's kind of like the same problem that we have with ODCRs, right? We've got these reserved instances. We're paying for them whether or not they're on. So we might as well just have them on all the time.
Right. You might as well make that your spare capacity, right? Just keep it in your own pool at that point. But then you have to engineer that, right? So the question is, like, is there some way that we can make this, like, it would be really interesting to see if there were a way to make this part of Cluster API, right? Where I can say, hey, look, I can have these extra nodes ready, and here's this methodology whereby I can use Cluster API to bring things in that are like already running or something, that would, then you could start to address that. Okay, I have a management cluster that serves several workload clusters, and I also have spare capacity that can be handed out to the workload clusters as needed. Like, some pattern around that would be really cool, I would think.
Especially the ability to move reserve claims between clusters that are in different places. Because sometimes we have to manage those, manage that kind of capacity. And there's nothing about that that's particularly automated with what we have like right now.
Yeah, well, these are good questions. I wish I had good answers.
We start simple and then we eventually get to the edge cases and conquer those. So
yeah, totally. That's kind of what I'm focused on right now, is like, let's just get this thing working in a very basic way. And then hopefully at that point we'll be in a good position to transfer it to the Kubernetes SIG org, and just, I'm kind of already predicting just making tons of issues to try and get people to help, because a lot of people are kind of lining up to say, like, how can I get in on this? And it's like, all right, let's do it. Let's figure it out. Okay, well, that's about it for me. I don't know. Was there anything else you want to talk about?
nope, that's it on my side too.
Cool. Well, appreciate the discussion, and I guess we'll just keep watching things and see how things are going. All right.
Great.
Have a good one, Jeremy.
All right. Have a good one. Bye.